Look at this figure. It consists of two squares, this one and this one. The outer square has the length of its sides equal to 100 centimeters and the sides of the inner square are equal to 70 centimeters. We have to find the area of the colored region. How do we find this out? Yes, we just have to remove the area of the inner square from the outer square. What's left is the colored region. So the area equals area of outer square minus the area of the inner square. Area of a square is side squared. So the area of the outer square will be 100 squared and the area of the inner square will be 70 squared. This will equal 10,000 minus 4,900. So we get the area of the colored region as 5,100 squared centimeters. To find the area of the colored region, all we had to do was subtract the area of the inner square from the area of the outer square. But this problem can be thrown at you in many ways. Sometimes you may be given the width of the colored region and the length of the side of one of the squares. Other times, you may be given the area of the colored region and the side of one of the squares and asked to find the side of the other square. The basic concept remains the same. Subtract the area of inner square from the outer to get the area of the colored region. Look at this figure now. It is a scaled down figure of a rectangular park. The length of the park is 70 meters and its width is 60 meters. There are two paths that cross each other in between. Both of them have a uniform width of 5 meters. This will be 5 meters and this too will be 5 meters. We have to find the area of the remaining portion of the park. Basically, it is the portion which does not include the paths. That is, these four regions. This problem is really simple, but also very interesting. Let ABCD be one of the rectangular paths, and let EFGH be the other rectangular path. And let MNOP be the intersection of the paths. So what will be the area of the remaining portion? It will be the area of the entire park minus the area of the paths. We find the area of the park first. Area of the rectangular park will be 70 times 60, which equals 4,200 squared centimeters. The area of the paths will be the area of rectangle EFGH plus the area of rectangle ABCD. Am I right in saying that? No, I'm not. This is the only tricky part of the problem. Observe that if we do this, we are counting the area of the intersection twice. Once for this rectangle and another time for this rectangle. So that we count it just once and not twice, we have to subtract it once from the total area of the paths. So we write minus area of quadrilateral MNOP. Since the width of the rectangle is 60 meters and the width of the path is 5 meters, area of quadrilateral EFGH will be 5 multiplied by 60. Similarly, area of rectangle ABCD is equal to 5 multiplied by 70. Since the widths of the paths are the same, the intersecting region is a square of side 5 meters. So we subtract 5 times 5 from the area of the paths. This 5 times 5 is the area of the intersection of the paths. Remember, if we do not subtract this value, it will mean that we are subtracting the path intersection twice from the area of the park. This will equal 300 plus 350 minus 25, which equals 625 squared meters. So the area of the remaining portion will be 4,200 minus 625. That gives us 3,575 squared meters. The area of these four regions together equals 3,575 squared meters, and that is the area of the remaining portion of the park.